So how do we graph a rational function that doesn't just have a in the numerator, but has an expression with x in the numerator as well? Let's start looking at our horizontal and our vertical asymptotes and figure it out from there. Remember, our horizontal asymptotes essentially tell us what value does y approach as x gets really large and really small. Now we're talking not just 10 or 20 or 100, we're talking about millions or billions or whatever. So if x gets a really, really large number, then does it really matter so much that we're adding 1 to that number? That won't make a big difference, will it? And equally in the denominator, as x gets really, really large, subtracting 3 can barely be noticed. So we could almost, just for the moment, pretend that this is not there. And then we have 4x over 2x, and then if x always has to be the same number, we can cancel this out, right? So essentially, as the x gets really, really large, then the y will get closer and closer, but never actually reach the number 4 over 2, which in other words is 2. So our horizontal asymptote has to be y is equal to 2. Let us just put that into the graph then. Okay, and now let's bring our function back. What about the vertical asymptote? When do we have a vertical asymptote? Whenever we have a number for x that would turn the denominator to 0, which is something that's not allowed. Well, then let's look at the denominator and only at the denominator and think about when will that denominator turn to 0? In other words, what x value will make this 0? We can solve this the algebraic way or do it the shortcut way. Take the 3, change the sign, and divide by 2. And that gives us a vertical asymptote, which is positive 3 over 2. Positive 3 over 2, or in other words, 1.5. So here goes our vertical asymptote. All right, and that pretty much determines our domain and range then. The domain will be all the x values such that x is not equal to 3/2. So we don't make the denominator turn to 0. And the range will be all the y values, but y can never be 2, or never actually will be 2. It will never reach that number. Let's find the x and y intercepts then. I'm going to start with the y-intercept. The y-intercept is going to be equal to 4 times 0 plus 1 over 2 times 0 minus 3. So we get 0 plus 1 over negative 3. In other words, negative 1/3. And as an ordered pair, that is 0, negative 1/3. Negative 1/3 down, little less than half. This is just a sketch. So here's where I'm going to put my point. So for the x-intercept, we really only have to look at the numerator. Remember, we said our denominator is not allowed to be 0 anyway. So the x-intercept, y will be 0 when the numerator turns to 0. So 0 is equal to 4x plus 1. Subtract 1 from both sides. We get negative 1 is equal to 4x. Divide everything by 4. And negative 1/4 is equal to x. Our x-intercept is at negative 1/4 and 0. Again, a fraction. This is not so nice to graph as any point that's directly on the grid line, but let's not worry about it. Let's just make a point roughly where we expect it to be, and that is here. So now let's keep this straight one more time. The denominator we used to determine the vertical asymptote. The numerator, on the other hand, we used to find our x-intercept. Now we're going to find just a few more points that we can use to help us graph. Would be nice to have some that are close to the intersection of our asymptotes. So I'm going to start with positive 3. So let's find what is f of positive 3. F of positive 3 is equal to 4 times 3 plus 1 over 2 times 3 minus 3. In other words, 12 plus 1 over 6 minus 3, which is nothing else than 13 thirds. 13 thirds is a little more than positive 4. So at positive 3, we have a y coordinate of 13 thirds, a little above 4. Let's find one which is a little closer to the horizontal asymptote. I'm going to use 5. F of 5 is equal to 4 times 5 plus 1 over 2 times 5 minus 3. And that is 20 plus 1 over 10 minus 3. 20 plus 1 is 21 over 7. In other words, 3. Yay, we got an integer here. This is our point. And since these points on the left are a little close, so let's find the y coordinate for an x value which is closer somewhere to the horizontal asymptote. I'm going to pick -2. So f of -2 is equal to 4 times -2 plus 1 over 2 times -2 minus 3. That is -8 plus 1 over -4 minus 3. In other words, -7 over -7, and that is +1. So at -2, we have a y coordinate of +1, and that now gives us enough points to go ahead and do our graph. This is the right part of our hyperbola, and this is the left part. Okay, well done, but let's go ahead and check it on our calculator. I already plugged the equation in for you, but when you do it yourselves, make sure that you use parentheses, because here you can only plug it in using a division sign for the fraction, and then you need parentheses or the order of operations is going to give you a different result. Be very careful with that. And let's press graph, and let's see what we have here. Where do we think our asymptotes are? I would say that the horizontal asymptote is at +2, just where we have it, and the vertical asymptote is definitely further to the right than the point 1, because here we are crossing the point 1, but doesn't seem to be crossing the point 2 just yet. So 1.5 is where we have it, and that looks fine. So let's talk about what did we do to find the asymptotes of a function that has this form. F of x is equal to ax plus b over cx plus d. To find the horizontal asymptote, what we did is we took essentially only the coefficients of the x term in the numerator by the denominator. So we divided a by c because we decided that b and d at that point won't matter that much anymore. And to find the vertical asymptote, we really have to think about the denominator only. We set the denominator equal to 0 and we solve, and then we get the number that cannot be in the domain, and that is exactly where a vertical asymptote will cross the x-axis. To the next example. First, let's find our horizontal asymptote, and we find it by looking at our coefficients here. The horizontal asymptote is y is equal to 5 over 2. Our vertical asymptote we will find when we take our denominator and set it to 0. X minus 6 is 0 when x is +6 over 2. In other words, +3. So our vertical asymptote is +3. Now let's go ahead and graph these. 5/2 is 2.5. So here is our horizontal asymptote. and our vertical asymptote is at positive 3. That also determines our domain and range. The domain is x such that x is not equal to 3, and the range is y such that y is not equal to 5/2. Let's find our x and y intercepts. The y-intercept is at 5 times 0 minus 1 over 2 times 0 minus 6. In other words, negative 1 over negative 6, or positive 1 over 6. 0, 1 over 6 are coordinates. 1 over 6 is just the tiniest little bit up on the y-axis somewhere here. Our x-intercept is again going to be where our numerator turns to 0. 5x minus 1 is equal to 0. That means 5x is equal to 1. Dividing by 5, x is equal to 1/5. 1/5 and 0 is our x-intercept. And again, the tiniest little bit to the right on our x-axis. Now, we already know the general direction of both ends of our hyperbola, so this doesn't help us too much. We would like to get a little bit of a better idea of how soon and how quickly those ends get close to the asymptotes. So let's find a few values. Let's start with finding f of 1. That is going to be equal to 5 times 1 minus 1 over 2 times 1 minus 6. 5 minus 1 over 2 minus 6 is 4 over negative 4. In other words, negative 1. So at positive 1, we have a y-coordinate of negative 1. Let's also find a couple which are on the other side of our vertical asymptote. For example, 5. F of 5 is equal to 5 times 5 minus 1 over 2 times 5 minus 6. In other words, 25 minus 1 over 10 minus 6. 24 over 4, which is 6. At positive 5, we have a y-coordinate of positive 6. And maybe one more. F of 7 is equal to 5 times 7 minus 1 over 2 times 7 minus 6. 35 minus 1 over 14 minus 6. 34 over 8, which can be simplified into 4 1/4. 4 1/4. So at positive 7, which is just the edge of our coordinate plane, we have a point which is slightly above 4. Okay, that should do it for sketching our hyperbola. Here is our left arm, and here is our right arm. Alright, the next one, I'm going to have you stop the video and try it yourselves, and then afterwards compare your answers with mine. Remember, you can get any number of points to help you graph, but you should have at least 2 on each arm of your hyperbola. Now go ahead and stop the video and try this next one yourselves. Okay, hopefully you got to the same point. Our horizontal asymptote is at 2 divided by negative 1, in other words, negative 2. Our vertical asymptote is at x is equal to negative 3. That means our domain is x such that x is not equal to negative 3, and our range is y such that y is not equal to 2. Our y-intercept, as we plug in 0 for x, we get 0 for y. That means that y-intercept is 0, 0. This is our origin, and that means that the x-intercept is the exact same point. All right? I took 4 numbers to get some points. F of 2 is negative 4 over 5, or almost negative 1. F of negative 2 is positive 4. That's the point over here. F of negative 4 is negative 8, just one step of our grid. And f of negative 6 is negative 4 over here. And that allows us to graph our hyperbola just like this. Good job, you guys. This is it for today, and I will see you in class.